My name is Laci. I am the project manager of the team and the coordinator.
Hello, I am Patrick. I help the teams work in both hardware and software. My main goal is to make sure that the CanSat operates reliably.
Hi, I'm Levente. I'm responsible for a part of documentation and for overview, supervision, and transparency for the team meetings. My goal is to delve into the world of the space exploration and learn more about hardwares.
Hello, my name is Balázs. I am responsible for the outreach program and 3D printing. I also take part in software development and I do basic soldering.
Hi, my name is Gary. I lead the software and hardware development of our CanSat. I design and build the PCBs, including soldering and assembly. I really love being part of the team because it inspires me and also others.
Our PETG-based chassis fits perfectly within the 66mm diameter limit, and the total mass is calibrated to 310 grams. The CanSat frame could withstand 105 kilograms of lateral downwards force. Our CanSat hardware is modular and robust, and it is designed so the primary mission succeeds even if other subsystems fail. The main panel can complete all primary mission tasks on its own and is kept permanently powered, as it cannot be switched off by the PDU. If the interport, primary CAN bus and redundant I2C communication fails, the system still operates using the main panel alone. The stacked PCB architecture improves vibration resistance, while the PDU provides a monitor, switchable power for non-critical modules, and data is sent via LoRa and stored on SD cards.
Our secondary mission simulates a landing on an Earth-like exoplanet. During descent, we measure atmospheric conditions like temperature, humidity, pressure, gas concentration, and ambient light. A downward-facing camera captures 4K footage, and our thermal camera records infrared data. We also film the parachute from the top panel to evaluate deployment and stability.
After recovery, we synchronize the videos with telemetry, so every frame matches altitude, speed, orientation, and sensor readings. We then analyze the combined dataset to identify regions of interest, such as unusual thermal patterns or gas changes. For reliable recovery, we deploy a visible powder trail, transmit GPS and DIMU-based position updates, and use our portable CanSat finder to locate the CanSat precisely.
During our drop tests, we verify the aerodynamic stability of the CanSat. The cross-shaped parachute provides a steady descent rate of 9.8 meters per second, protecting our internal sensors upon impact.
For the radio test, we utilized our 800 and 68 MHz LoRa devices. We achieved a stable connection at a range of 4 km with successful telemetry transmission.
Our CanSat software is built to be both strong and reliable, ensuring it works well even in difficult conditions. You can easily update important settings on the spot using Bluetooth, or you can use USB and LoRa as backup options. The system uses a smart, mode-based status handler to manage itself automatically during the entire mission. Finally, its power-saving design allows the device to run for a long time without running out of energy.
We put strong focus on clear and correct work in our team, so we work with strict internal deadlines. It is true that in January the work was a little delayed because of external reasons. The manufacturers were very busy, so at the time of the video recording, we were still waiting for the flight model PCBs. However, we are sure that we will fully finish everything by the end of February. Our engineering model is fully working.
On the screen, you can see our social media QR codes. Feel free to scan them to connect with us. Our mission is to inspire and educate students and the public about STEM fields. To achieve this, we recently participated in the Pécsi Tudományfesztivál and the második hazai űrkongresszus. We also had a 30 minutes long video interview in Pécs TV.
We are the satellite assembly team, and we are really excited about the results. See you at the countdown event.